Let me ask you something that sounds crazy. There are about 400 billion stars in our galaxy. 400 billion. And we now know that most of them have planets. So there are probably more planets in the Milky Way than there are grains of sand on all the beaches of California. And the universe has been cooking for over 13 billion years. That is a long time. That is plenty of time for somebody, somewhere, to figure out how to build a rocket and come visit us. So where are they? Why is the sky so quiet? Why hasn't a single alien knocked on the door? By the time we are finished here today, you will understand why the distances between the stars are not just large, they are savagely, absurdly, comically large, and why the laws of physics, the real laws, not the ones you see in the movies, make it extraordinarily unlikely that any alien creature will ever park a spaceship on your lawn. And I am not guessing. I am going to show you with numbers. Real numbers. The kind nature actually uses. Now, let me start with something familiar. Something you already know, but maybe haven't thought about carefully enough. You have probably driven a car on a highway. Maybe you have driven from Los Angeles to New York. That is about 3,000 miles. It takes you, maybe 3 days if you are in a hurry? You get tired. You stop for gas. You eat a bad sandwich at some roadside place. It is a long trip. 3,000 miles feels like a serious distance when you are the one sitting behind the wheel. Now here is the trick. The nearest star to our sun, a little fellow called Proxima Centauri, is about 4 light years away. That does not sound so bad until you convert it into miles. 4 light years is roughly 25 trillion miles. Let me say that differently so it sinks in. If you lined up your Los Angeles to New York road trip end to end, you would have to make that drive about 8 billion times to cover the distance to the nearest star. 8 billion coast-to-coast road trips, just to reach the closest one, the nearest neighbor. And that neighbor is practically sitting in our lap compared to most of the galaxy. Now somebody says, well, Feynman, we would not drive. We would use a rocket. Fine, let us use a rocket. The fastest thing we have ever built and launched into deep space travels at about 40,000 miles per hour. That sounds fast. And it is fast if you are trying to get from here to the grocery store. But at 40,000 miles per hour, do you know how long it takes to reach Proxima Centauri? About 70,000 years. 70,000 years. That is longer than all of recorded human civilization. We have only been writing things down for about 5,000 years. You would need to sustain a mission 14 times longer than the entire history of writing. Your great, and I would have to say great about 2,000 more times, grandchildren would be the ones arriving. If the ship still worked. If anyone was still alive. If anyone still remembered why they left. So you see, when people say the universe is big, they are not exaggerating. If anything, they are understating the problem. The universe is not just big. It is so big that the word big loses all meaning. It is as if we need a new word. The universe is something else entirely. It is a kind of emptiness that the human mind was simply not built to comprehend. We evolved to worry about lions on the savannah, not about the gaps between stars. Now wait, let us be fair. Maybe the aliens are smarter than us. Maybe they have faster ships. Let us give them a very generous speed. Let us say they can travel at 10% the speed of light. That is about 67 million miles per hour, enormously faster than anything we can build. At that incredible speed, the trip to Proxima Centauri still takes 40 years. 40 years in a tin can hurtling through the emptiest, coldest, most hostile vacuum you can imagine. And that is just to the nearest star. If they want to visit something in the middle of the galaxy at 10% the speed of light, it takes about 1 million years. 1 million years, one way. No round-trip discount. But let us not give up on them yet. Let us push the speed even higher. Let us say they manage to go at half the speed of light. Now we are talking about something truly extraordinary. At that speed, every tiny speck of dust floating in interstellar space hits your ship like a bomb. A grain of sand at half the speed of light carries the energy of a hand grenade. and space is not perfectly empty. There are about 1 or 2 hydrogen atoms per cubic centimeter out there. At half the speed of light, those atoms become a vicious stream of radiation, like standing in front of an X-ray machine that never turns off. Papers have been written about this. The calculations show that at 10% of the speed of light, the radiation dose from interstellar hydrogen alone is about 60 rems per second. The lethal dose for a human is about 500 rems. You would be dead in less than 10 seconds. At higher speeds, it gets even worse. You would need a radiation shield, meters thick, made of something very dense, which of course adds to the mass, which makes the fuel problem worse, which is the same spiral we keep running into. You see, these problems do not exist in isolation. They compound each other. The faster you go, the more energy you need, and the more radiation shielding you need, which means more mass, which means more energy. The physics is conspiring against you from every direction. It is as if the universe has been carefully designed to prevent things from traveling between stars. I do not think it was designed that way, of course. It is just how the numbers work out. But the effect is the same. Even at half the speed of light, crossing the galaxy takes 200,000 years, and the galaxy is just one out of hundreds of billions. So here's the situation. The distances are not just a nuisance. They are a wall built into the very structure of the universe by the laws of physics. And the most important law, the one that makes this wall truly impassable, is the speed of light. Let me explain why the speed of light matters so much, because people get confused about this. They think it is just a speed limit, like the signs on the highway that say 55 miles per hour, as if you could go 56 if you were willing to pay the fine. It is not like that at all. The speed of light is not a rule someone made up. It is built into the geometry of space and time. Einstein showed us that space and time are not separate things. They are woven together into a single fabric, and the speed of light is the exchange rate between them. When you try to go faster and faster, something very strange happens. Time slows down for you. Your mass increases, not by a little. It increases without limit. As you approach the speed of light, your mass approaches infinity. And what does it take to accelerate an infinite mass? Infinite energy. You cannot get there. It is not that we lack the technology. It is that the universe says no. Now, somebody always says, but Feynman, what about warp drives? What about wormholes? What about bending space? Fine. I love speculation. Speculation is fun. But let us be careful and distinguish between what is fun to think about and what is physics. A warp drive is an idea that comes from a set of equations that were published as a mathematical curiosity. They show that, in principle, you could contract the space in front of your ship and expand the space behind it so the ship rides a wave of space-time. Beautiful idea. The trouble is, to do it, you would need a form of energy that has negative mass, not just negative charge. Negative mass. Nobody has ever observed negative mass. We have no reason to believe it exists. It would violate several things we hold very dear in physics, like the fact that energy should be positive. The whole scheme requires something we have never seen and have very good reasons to think cannot exist. That is not engineering. That is wish-making. Wormholes are the same story. Yes, the equations of general relativity allow for the possibility of tunnels through space-time. But every solution we know of is either unstable, meaning it collapses before anything could pass through, or it requires exotic matter with negative energy density, which is the same problem as before. We do not have it. We cannot make it. And there are strong theoretical reasons to think that nature does not allow stable, traversable wormholes. The universe seems to have rules against shortcuts. So let me restate the situation plainly, as if I were talking to a bright 12-year-old, because this is important and I want to be clear. The stars are incredibly far apart. The fastest possible speed in the universe is the speed of light, and you cannot even reach that speed because it would take infinite energy. Even at large fractions of the speed of light, the trips take centuries or millennia, and we have no physics, not speculation, not fiction, real physics that shows a way around this. That is the reality check. Now let me make it worse. because I have only talked about distance and speed so far. I haven't talked about energy. Suppose you want to send a spaceship to another star, a real spaceship with people on it, or at least with something heavy enough to do something useful when it arrives. Let us say the ship weighs about 100,000 kilograms. That is about the weight of a loaded Boeing 737. Not enormous. A modest little interstellar boat. Now, to get that ship up to even 10% of the speed of light, do you know how much energy you need? About 4 times 10 to the 23rd joules. Let me put that in perspective. The total energy output of all human civilization in a year, all the power plants, all the cars, all the factories, everything, is about 5 times 10 to the 20 joules. So the energy needed to push one modest spaceship to 10% of the speed of light is roughly 1,000 times the total annual energy output of the entire human race for one ship, one trip, one way. And remember, you also have to carry the fuel. This is the tyranny of the rocket equation. The fuel has mass. That mass needs fuel to push it. That additional fuel also has mass, which needs more fuel. The numbers spiral out of control with horrifying speed. If you try to use chemical rockets, the kind that took us to the moon, the amount of fuel needed to reach even 1% of the speed of light is more than the mass of the observable universe. I am not making this up. Do the arithmetic. It is one of those calculations where the answer comes out and you just stare at it and laugh, because what else can you do? Even if you use nuclear fusion, the best energy source we can imagine having in the foreseeable future, the fuel-to-payload ratio for a trip to the nearest star at a reasonable speed is thousands to 1. You need a fuel tank the size of a skyscraper for every passenger. And if you want to stop at the other end, you need to bring fuel for deceleration too, which roughly doubles the problem, or actually much more than doubles it because of the exponential nature of the rocket equation. There is an idea that you could use antimatter. Matter-antimatter annihilation converts 100% of mass into energy. It is the most efficient fuel conceivable, but we can only produce antimatter in tiny quantities, a few atoms at a time, at enormous expense. The total amount of antimatter ever produced by humanity, if you added it all up, would not heat a cup of coffee. And to send our little spaceship to the nearest star, you would need tons of the stuff. Tens of tons. Where does it come from? Nobody knows. It certainly does not grow on trees. Now I want you to think about what this means for aliens. People assume that if a civilization is sufficiently advanced, all these problems go away. They wave their hands and say, oh, they must have figured it out. But the laws of physics are not local ordinances. They do not change because you are smarter. The speed of light does not increase because your civilization is 1,000,000 years old. The rocket equation does not get more forgiving because you have better computers. E equals mc squared is the same on their planet as it is on ours. Physics is universal. That is what universal means. So when somebody tells me aliens have visited Earth, I have a very simple question. How? How did they get here? And I do not mean how in some vague philosophical sense. I mean, show me the physics. Show me the propulsion system. Show me where the energy comes from. Show me how they survived the radiation, the dust impacts, the decades or centuries of travel. Show me how they solved the fuel problem. Because until someone can answer those questions, the claim that aliens are visiting us is not just unproven, it is in violent conflict with everything we know about how the universe works. Now, let me tell you about a very famous lunch. In the summer of 1950, at Los Alamos, some physicists were walking to lunch. Among them was Enrico Fermi. They were talking about a cartoon they had seen in a newspaper, something about flying saucers. They were joking around, as physicists do, about whether aliens might be visiting Earth. And Fermi, who was one of the quickest minds of the 20th century, suddenly said something that silenced the table. He said, "Where is everybody?" What Fermi realized in that instant was something both simple and profound. The galaxy is very old. Our sun is a middle-aged star. There are stars billions of years older. If life can arise on planets, and if intelligence can evolve, then somewhere in the galaxy, civilizations should have arisen billions of years before us. A civilization with even a million-year head start could have colonized the entire galaxy by now, even at slow speeds. Even at 1% of the speed of light, you can cross the galaxy in 10 million years. That sounds like a long time, but the galaxy is over 10 billion years old. There has been more than enough time for somebody to spread everywhere. And yet, nothing. No signals, no artifacts, no probes, no visitors, not a single piece of confirmed evidence that anyone else is out there. The sky is silent, the solar system is empty. The galaxy, as far as we can tell, shows no signs whatsoever of being colonized or even visited by an advanced civilization. This is what people call the Fermi Paradox, and it is one of the deepest questions in all of science. Now, there are many possible answers. Let me walk you through the main ones, because they are all interesting and some of them are quite disturbing. The first possibility is the most straightforward. Maybe we are alone. Maybe intelligent life is so fantastically rare that in this entire galaxy of 400 billion stars, we are the only ones who ever figured out how to make a radio. This sounds arrogant, but it might be true. Let me explain why. There's a famous equation proposed by an astronomer named Frank Drake. It is not really an equation in the physics sense. It is more like a way of organizing your ignorance. It says, take the rate of star formation in the galaxy, multiply by the fraction of stars that have planets, multiply by the number of planets per star that could support life, multiply by the fraction of those where life actually arises, multiply by the fraction where intelligence evolves, multiply by the fraction that developed technology we could detect, multiply by the average lifetime of such a civilization. The result is the number of detectable civilizations in the galaxy right now. The problem is, we do not know most of these numbers. We have gotten pretty good at the first couple. We know roughly how many stars form each year, about 1 or 2 in a galaxy like ours. We know that most stars have planets. We are getting better at estimating how many are in the habitable zone, the region where liquid water could exist. For these first few terms, the numbers are encouraging. There are probably billions of potentially habitable planets in the galaxy. But then you hit the brick wall. What fraction of habitable planets actually produce life? We have no idea. We have exactly one example, Earth. And one example tells you almost nothing about a probability. It is like flipping a coin once, getting heads and trying to calculate the odds. You cannot do it. Then, what fraction of planets with life develop intelligence? Again, one example. And if you look at the history of life on Earth, intelligence took about 4 billion years to appear. For most of that time, life was just microbes, single cells, blobs. Intelligence is not some inevitable endpoint of evolution. It is one particular trick that one particular lineage stumbled into, probably by accident. Evolution does not have goals. It does not aim for intelligence. It just fiddles around with whatever works. And most of what works is bacteria. Think about it this way. Life on Earth has been around for nearly 4 billion years. In all that time, how many species have developed technology? 1. Out of billions of species that have existed, exactly 1 has built a radio telescope. That is not a trend. That is a fluke. And let us look at this more carefully, because the details are revealing. For the first 2 billion years, life on Earth was nothing but bacteria. Single cells, no eyes, no brains, no anything. Just little chemical machines churning away in the ocean. Then something astonishing happened. One bacterium swallowed another one, and instead of digesting it, the two formed a partnership. That was the origin of complex cells, eukaryotes. It took 2 billion years to happen. 2 billion years. And as far as we can tell, it only happened once. Every complex organism on Earth, every plant, every animal, every fungus is descended from that single event. That is not a gradual, inevitable process. That is a freak accident that took 2 billion years to occur. Then, once you had complex cells, it took another billion years or so before multicellular life appeared. Then, hundreds of millions more years before anything with a brain evolved. then hundreds of millions more before anything you would call intelligent showed up. Each of these steps seems to be very difficult, very unlikely. The fact that they all happened on Earth does not tell us that they commonly happen elsewhere. It might just mean we got extraordinarily lucky over and over again. And here is something else that troubles me. Even on Earth, it very nearly did not happen. If that asteroid had not hit 65 million years ago and wiped out the dinosaurs, there is no reason to think mammals would have risen to dominance. We might still have a planet ruled by dinosaurs, and dinosaurs, for all their 170 million years of success, never showed the slightest inclination toward building anything. The fact that we exist at all is the result of a cosmic accident. There is another thing people do not think about enough, and that is timing. Even if civilizations do arise in the galaxy, they have to exist at the same time to detect each other. The galaxy is over 10 billion years old. A technological civilization might last, 10,000 years? 1,000,000 years if it is very stable? That is like two fireflies blinking in a dark field the size of a continent. The chances that their flashes overlap in time are tiny. Most civilizations that ever existed in the galaxy are probably already dead. And most that will ever exist have not yet been born. We might be in the right place but the wrong time, or the right time but the wrong place. The universe does not coordinate its schedules for our convenience. So when you multiply all these unknown fractions together, you can get almost any answer you want. You can get millions of civilizations, or you can get a number much less than one, meaning we are likely alone. The Drake equation is not a calculator. It is a mirror. It shows you your assumptions, not your conclusions. Now let me talk about another possibility. Let us suppose, just for the sake of argument, that intelligent civilizations are common. They arise all over the galaxy. What then? Well, maybe they do not last very long. This is a dark thought, but it has a certain logic to it. Look at us. We have had nuclear weapons for about 40 years now. We have the ability to destroy our entire civilization. We have been in situations where we came very close to doing so. The Cuban crisis, for example. How long can a civilization maintain the technology to destroy itself without actually doing it? 100 years? 1,000? 10,000? Nobody knows. Maybe the answer to Fermi's question is that civilizations tend to kill themselves. They invent weapons before they invent wisdom. They ruin their planet's atmosphere, or they start wars they cannot stop, or they build machines that replace them. There are dozens of ways a civilization could end itself, and the longer the list gets, the more plausible this explanation becomes. There is a related point worth making here. Some people have proposed a classification system for civilizations based on how much energy they use. A fellow named Kardashev suggested 3 levels. A Type 1 civilization uses all the energy available on its planet, about 10 to the 16th watts. A Type 2 civilization harnesses all the energy of its star, about 10 to the 26th watts. Think of it as building a shell around the entire sun and capturing every photon. A Type 3 civilization uses the energy of its entire galaxy. Now, here is why this matters for our discussion. A Type 2 or Type 3 civilization would be detectable, not by their radio signals, not by their spacecraft, but by their waste heat. Thermodynamics is unforgiving. Any civilization that uses energy must radiate waste heat. It is the second law. You cannot get around it. A civilization that had enclosed its star in a shell, what some people call a Dyson sphere, would be invisible in visible light, but would glow brightly in the infrared. We have surveyed millions of stars. We have not found a single one that shows the signature of a Dyson sphere. Not one. Not even a candidate that has survived careful analysis. And a Type 3 civilization, one that harnesses the power of an entire galaxy, it would be visible across the observable universe. Entire galaxies would look different in the infrared. We have looked at that too. Nothing. The galaxies look like galaxies. No sign of engineering on a cosmic scale. This is another way of stating Fermi's puzzle, and it makes it sharper. We are not just looking for radio signals. We are looking for the thermodynamic footprint of any civilization that uses significant amounts of energy, and we see nothing. There is a concept people call the Great Filter. The idea is simple. Somewhere between raw chemistry and a galaxy-spanning civilization, there is a step that is almost impossible to get past. Something filters out nearly all life before it reaches the stars. The question is, where is the filter? Is it behind us or in front of us? If the filter is behind us, that is good news. It means the hard part was something like the origin of life, or the jump from single cells to complex cells, or the evolution of intelligence. We already made it through. The reason the galaxy is quiet is that almost nobody else ever got this far. We are rare, we are lucky, we are special, not because we are wonderful, but because we beat astronomical odds. If the filter is in front of us, that is very bad news. It means civilizations commonly reach our level of development and then destroy themselves. It means we are walking toward a cliff that we cannot see, and that virtually everyone who has walked this way before has gone over the edge. I do not know which it is. Nobody does. But I will tell you this: the silence of the sky is eerie, and it should make us think very carefully about our choices. Now, let me come back to the physics, because there is a common misconception I want to address. People say, aliens might use technology we cannot imagine. They say, you cannot rule out faster than light travel just because we do not know how to do it. And this sounds reasonable, it sounds open-minded, but it is not. Here is why. The speed of light is not a feature of our current technology. It is not a feature of our current understanding. It is a feature of the structure of space-time itself. Every experiment ever performed, every observation ever made, every prediction of special and general relativity, which are among the most precisely tested theories in all of science, confirms that the speed of light is an absolute limit. It is woven into the equations at the most fundamental level. To exceed the speed of light, you would not just need better engines, you would need different physics, different laws of nature, a different universe. Now, I am a physicist, and I know better than to say anything is absolutely impossible. Maybe there is a loophole we have not found. Maybe the universe has a secret passage. But the evidence against it is overwhelming. Extraordinary claims require extraordinary evidence, and nobody has produced even ordinary evidence for faster-than-light travel. Not a hint, not a whiff, not the slightest tremor in any experiment ever conducted. It is like this. Suppose somebody tells you they can build a perpetual motion machine, a machine that runs forever without any energy input. Now, you cannot prove with absolute certainty that such a machine is impossible. Maybe there is some subtle physical law we have missed, but every attempt to build one has failed. Every theoretical analysis says it cannot work. The laws of thermodynamics, which have never been violated in the entire history of science, say no. At some point, the reasonable thing to do is to say, this is almost certainly impossible, and to act accordingly. That is not closed-mindedness. That is science. Science is about what is more likely and what is less likely, not about proving things impossible. Let me give you another thought experiment. This one really drives the point home. Suppose there is an alien civilization around a star that is 1,000 light years away. Not very far by galactic standards. Close, really. And suppose they are very smart and very advanced. They want to send us a message. Just a radio signal, not a ship, just a message at the speed of light. How long does it take to arrive? 1,000 years. If they sent the message around the time William the Conqueror was invading England, it would be arriving about now. And if we sent a reply, they would receive it 1,000 years from now. A conversation with a 2,000-year round-trip time. You would not call that chatty. But it gets worse. Radio signals, like light, obey the inverse square law. The power of the signal decreases as the square of the distance. Double the distance, and the signal is 4 times weaker. 10 times the distance, 100 times weaker. 100 times the distance, 10,000 times weaker. At 1,000 light years, the signal from a transmitter as powerful as everything humanity has ever built would be so faint that it would be completely drowned out by the natural radio noise of the galaxy. You would not even know it was there. Let me give you an analogy for the inverse square law, because it is one of the most important ideas in all of physics, and people do not appreciate how ruthless it is. Imagine you are standing in a field holding a candle. Your friend is standing 10 feet away. They can see the candle clearly. Now, move them to 100 feet. The candle is 100 times dimmer, not 10 times. They can still see it, barely. Now move them to a mile. The candle is completely invisible. The light has spread out so much that there is not enough landing on their eye to register. Now imagine your friend is on another continent, or on the moon, or at the nearest star. At each step, the signal gets not just weaker, but catastrophically weaker. The inverse square law is merciless. This is why the idea that aliens could pick up our television broadcasts is a fantasy. Our television signals are incredibly weak by cosmic standards. They spread out in all directions, getting weaker and weaker with distance. By the time they reach the nearest star, they are trillions of times fainter than the background noise of the galaxy. They are undetectable. We have been broadcasting for less than a century, and those broadcasts have reached a grand total of about 100 light years, which is nothing. 100 light years contains maybe a few thousand stars. The galaxy has 400 billion. To send a detectable signal across 1,000 light years, you would need a transmitter of staggering power. We are talking about the energy output of a small star focused into a tight beam pointed directly at us. That requires not only enormous energy, but also the knowledge that we exist and exactly where we are. Why would they bother? They cannot possibly know about us. Light from Earth has only traveled about 100 light years into space, and for most of that time, our radio signals have been too weak to be detected at any significant distance. So the idea that aliens are sending us messages and we are just not listening carefully enough is wishful thinking. The physics of signal propagation in space is brutal. Signals fade. Distances are vast. The galaxy is noisy. Even with the best receivers imaginable, the odds of picking up an alien signal are very small unless the transmitter is very close and very powerful and pointed right at us. The universe is not a telephone network. It is more like shouting across the Grand Canyon in a thunderstorm. Now I want to pause here and address something that comes up every time I talk about this. Somebody always says, but what about flying saucers? What about all those reports? I had a conversation about this once. A fellow said to me, you cannot prove that flying saucers are impossible, therefore they might exist. And I said, you are right, I cannot prove they are impossible. But from my knowledge of the world that I see around me, I think it is much more likely that the reports of flying saucers are the results of the known irrational characteristics of terrestrial intelligence than of the unknown rational efforts of extraterrestrial intelligence. Let me unpack that. We know that people make mistakes. We know that people see things that are not there. We know about optical illusions, about atmospheric phenomena, about the planet Venus being mistaken for a spaceship by police officers in 11 counties. We know about the psychological need to believe in something wonderful. We know about hoaxes. We know about attention-seeking. We know about all of these very well-documented features of human behavior. On the other hand, we know nothing about alien visitors. Nothing. Not a single piece of confirmed physical evidence. No artifact. No material. No signal that could not be explained by something else. Not one observation that withstands careful scientific scrutiny. So I have two explanations for flying saucer reports. One involves well-known, well-documented features of how human beings perceive and interpret the world. The other requires alien civilizations to solve every single one of the impossible physics problems I just described. Travel for thousands of years. Arrive at Earth, buzz around our military bases for a while, and then leave without giving us anything definitive. Which explanation is more likely? I think the answer is obvious. And that is all I am saying. I am not saying aliens cannot exist. I am saying the evidence for their visiting us is not evidence at all. It is stories. And stories, however compelling, are not data. Let me now take you through a thought experiment that I find very illuminating. It is about what I call the galactic lottery. Imagine the galaxy as a city, a very big city. It has 400 billion houses in it, one for each star. Now, some fraction of these houses have families living in them, maybe 1 in a million, maybe 1 in a billion. We do not know. But let us be generous and say 1 in a million. That gives us 400,000 families in the city. Now, these families live very far apart. Each house is separated from its nearest neighbor by miles and miles of empty desert. The families cannot drive because there are no roads. They cannot fly because the air is too thin. They can only walk, and they can only walk at a certain speed, and that speed is very, very slow compared to the distances involved. Some of the families have figured out how to shout. They shout into the desert, hoping that somebody will hear them. But the desert is so vast and so noisy, with wind and sandstorms, that the shouts get lost before they reach the next house. Maybe a few families close together can just barely hear each other if they shout very loudly and listen very carefully. But most families live and die without ever knowing that anyone else exists. That is the galaxy. That is our situation. We are one family in a vast, mostly empty desert, shouting into the wind and listening for a reply that may never come. Now, someone might say, but the galaxy has been around for billions of years. Surely somebody somewhere would have figured this out by now. Surely somebody would have sent probes, even if they could not come themselves. This is a good point, and it is basically Fermi's argument. Let me walk you through it carefully, because when you do, it becomes even more striking. There is an idea from a mathematician named von Neumann about self-replicating machines. The concept is simple and terrifying. You build a probe, you send it to another star system. When it arrives, it uses the raw materials it finds there, asteroids, dust, whatever, to build copies of itself. Those copies fly off to other star systems and do the same thing. Each generation doubles. After one generation, you have 2 probes. After 2, 4. After 10, 1,000. After 30, 1,000,000,000. This is the power of exponential growth, which is the most powerful force in mathematics. Now, even if each probe takes 1,000 years to travel between stars, and even if it takes another 1,000 years to replicate itself upon arrival, the entire galaxy, all 400 billion stars, could be completely saturated with probes in about 50 million years. That sounds like a long time. But the galaxy has been around for over 10 billion years. There has been time for this process to run from start to finish 200 times over. Think about that. Even with very modest technology, much more modest than anything a truly advanced civilization would possess, the galaxy could have been explored and catalogued many times over. Every star system, including ours, should have probes in it. Little mechanical visitors, sitting quietly on the moon or drifting through the asteroid belt, waiting to be discovered. And yet, nothing. No probes, no artifacts, no ancient machines, no signals, no evidence of any kind. What do we make of this? Well, there are several possibilities, and I want to be honest with you. We do not know the answer. But let me give you my sense of the situation. First, it is possible that we really are alone, or nearly alone. The origin of life, or the origin of intelligence, or both, might be so improbable that we are the only ones in the galaxy. This is consistent with the silence. Second, it is possible that civilizations arise but do not expand. Maybe the desire to colonize the stars is a peculiarly human fantasy. Maybe most intelligent species are content to stay home. Maybe the costs of interstellar travel are so enormous that no civilization, no matter how advanced, ever considers it worthwhile. This is what Fermi himself seems to have believed. Third, it is possible that civilizations arise, flourish briefly, and then destroy themselves. This is the pessimistic answer, and it carries a warning. Fourth, maybe we are looking in the wrong way, or not looking hard enough. We have only been searching for alien signals seriously for about 30 years, and our surveys have covered only a tiny fraction of the sky at a tiny range of frequencies with limited sensitivity. Maybe the signals are there and we have simply not found them yet. There is a fifth possibility that I hear sometimes, and I have to tell you why I do not find it very convincing. It is called the zoo hypothesis. The idea is that the aliens know we are here, but they have decided not to interfere. They are watching us. Like scientists observing animals in a nature preserve, they have a policy of non-contact, a galactic prime directive, and they're all following it. Now, this is a lovely idea for a story, but think about it as physics. Think about it as a claim about reality, and it falls apart rather quickly. First, it requires every single alien civilization in the entire galaxy to agree on the same policy. Every one. Not one renegade. Not one curious teenager. Not one dissenting faction that says, let us just go say hello. In the entire history of humanity, we have never achieved unanimous agreement about anything. The idea that thousands of independent alien civilizations spread across 100,000 light years of space would all independently decide on the same non-contact policy and enforce it perfectly for billions of years is frankly absurd. It requires a degree of galactic coordination that seems far less likely than the simpler explanation, which is that nobody is out there. Second, even if such a policy existed, it would not explain the absence of probes or ancient artifacts. A civilization that visited the solar system 1 billion years ago would not have known that intelligence would arise on Earth. They would have had no reason not to leave a marker, a probe, a base on the moon. And 1 billion years is plenty of time for us to find it. We have looked. There is nothing there. So the zoo hypothesis, while entertaining, does not hold up to scrutiny. It explains the silence only by invoking something even harder to believe than the silence itself. Each of these is plausible. I lean toward a combination of the first and the second. I think life might be common, but intelligence is rare, and I think the distances between stars are so immense that even advanced civilizations find it not worth the trouble to travel. But I want to be very clear, I am speculating. This is an area where honest speculation is allowed, provided you label it as such, and I am labeling it. Now, some people find this depressing. They want the universe to be full of friends. They want Star Trek to be a documentary. And I understand that desire. It is a beautiful dream. But nature is not obligated to be what we want. Nature is what it is. And what it is, as far as we can tell, is very quiet. But here is where I want to turn the whole thing around. Because I think the silence of the sky, properly understood, is not depressing at all. It is inspiring. Let me explain. If we are alone, or nearly alone, then what we have here on Earth is precious beyond measure. This thin film of air and water, clinging to the surface of a small rock, orbiting an ordinary star, in the suburbs of an unremarkable galaxy, might be the only place in the entire cosmos where anyone is looking up at the stars and wondering what they mean. That is extraordinary. That is, if you will forgive a physicist for using such a word, sacred. Every painting, every symphony, every scientific discovery, every act of kindness, every joke told around a dinner table might be utterly unique in all the universe. There might be nowhere else in all those billions of galaxies where anyone is writing poetry or proving theorems or falling in love. If that is true, then we have a responsibility that goes far beyond anything we usually think about. We are the custodians of something irreplaceable. And even if we are not alone, even if there are other civilizations scattered across the galaxy, separated by impossible distances, the same lesson holds. We cannot count on anyone coming to save us. We cannot expect a benevolent alien race to descend from the sky and fix our problems. Whatever we do with this planet, whatever we make of ourselves, it is up to us. There is no cavalry coming over the hill. The cavalry is us. Now, I want to say something about the nature of scientific thinking, because this whole question about aliens is a wonderful example of how science actually works. Science does not deal in certainties. It deals in probabilities. When I say aliens will never arrive, I do not mean I can prove it with absolute mathematical certainty. I mean that, given everything we know about physics, about the structure of space-time, about the distances between stars, about the energy required for travel, about the signals we have and have not detected, the probability of alien beings physically arriving at Earth is so small that it might as well be zero. And that is how science talks. We say what is more likely and what is less likely. We say what the evidence supports and what it does not. We do not deal in absolute proof, because absolute proof is for mathematics and whiskey advertisements. In science, We deal with the weight of evidence, and the weight of evidence here is overwhelming. Can I be wrong? Of course I can be wrong. Science is always open to new evidence. If tomorrow somebody found an alien artifact buried in the Antarctic ice, I would be the first one to admit I was wrong, and I would be delighted to be wrong, because that would be the most exciting discovery in the history of the human race. I am not hoping to be right. I am following the evidence where it leads. But until that evidence arrives, and I mean real evidence, not stories, not blurry photographs, not testimony from people who saw something they could not explain, real, physical, testable, repeatable evidence, the rational conclusion is that we are, for all practical purposes, alone, at least locally, at least for now, and probably forever. Let me tell you one more thing, and then I will let you go. This is about what I think is the real lesson of all this. The universe is not made for us. It was not designed with human beings in mind. The distances between the stars are not obstacles put there for us to overcome. They are just the way things are. The speed of light is not a challenge. It is a fact. The laws of physics are not walls to be broken through. They are the rules of the game, and they apply to everyone, everywhere, for all time. And when I really think about that, when I really let it sink in, I do not feel small. I feel amazed, because somehow, on this one tiny planet, the universe managed to produce creatures that can figure all of this out. We can measure the distance to the stars. We can calculate the energy needed for interstellar travel. We can write equations that describe the curvature of space-time. We can look at the silence of the sky and ask what it means. That is remarkable. That is the real miracle. Not that aliens might exist, but that we do. The universe is under no obligation to make sense to us, and yet it does. It makes beautiful, elegant, precise sense if you are patient enough and honest enough to listen to what it is actually saying, rather than what you wish it were saying. And what it is saying, with perfect clarity, is this: the stars are very far away. The speed of light is the law. Energy is not free, and the silence of the sky is telling us something important. It is telling us that whatever life exists in this universe, wherever it exists, it is almost certainly alone, separated from every other form of life by gulfs so vast that they might as well be infinite. So take care of this place. Take care of each other, because as far as the laws of physics can tell us, this might be all there is. And that, my friends, is the reality check. Now, I have talked for a long time, and I want to hear from you. So let me leave you with a question, and I would be genuinely curious to know your answer. If you could send one message into space, aimed at a star 1,000 light years away, knowing that the reply, if it came, would arrive in 2,000 years, what would you say? Think about that.